Uh, Good afternoon, everyone. I want to welcome you to my lecture today. Of course, today the focus is going to be on research design. You remember the other time, research design, and under research design, we got experimental studies and observational studies, and of course, we've been focusing on observational studies. So in today's lecture, we're going to focus more on observational studies. So what I need from you is to pay attention in case you don't understand. And let me also let me say this in my class. I want you to pay 100% attention. I don't allow students doing something that is totally different from this course in my class. Okay, so when you are here, I need your 100% attention. Okay, does that make sense? Okay, so in the outline, I'm actually um going to talk about from association to causation. Of course, when I was walking you through experimental study the other time, we're only able to conclude on causation with experimental study because of the fact that we use what I call the principle of randomization, and that has eliminated confounding effects. So, and you also, I told you the other time, even though experimental study has uh, you know, a very strong statistical power compared to observational study, but there could be some ethical issues to cost. And in some situations, of course, experimental study may not be feasible. And how do we, is there a way we can also bring something in into observational study for us to be able to conclude on causation? And of course, the answer is yes, because today I'm actually going to tell you, uh, what Sir Otto, he did in 1965 in his article, where he gave us some kinds of guidelines on how to evaluate some evidences before we can conclude on causation. And I'm also going to walk you through types of observational studies. Okay, so of course, I told you the other time, we find ourselves in a world where we actually want to observe and investigate effects of a particular variable on another variable. So what we're going to be talking about here is talking about cause and effects. Okay, now of course, I told you in observational study, we don't conduct experiment, we don't control variable. What we only do is to observe and analyze, the kind of relationship between, the variables. Okay, of course, and that was why you can see cannot use to establish cause and effect. But of course, we got some stuff that we can do that we make that conclusion to be possible. So in the vocabulary between the variables. Okay, of course, and that was why you can see cannot use to establish cause and effect. But of course, we got some stuff that we can do that we make that conclusion to be possible. So in the vocabulary, please, I need you to pay attention because when you are working with someone or you're giving statistical input or not or advice to a client, I think you need to watch out for what is explanatory variable and what is response variable. So take a look at that. Now, Let's take a look at from association to causation now. And I present to you three potential scenarios, okay, for the association between A and B, and they want it to match up. Okay, if I want to match up, you take a look at number one, ice cream sales and temperature. Of course, that is, glaring that in a very high temperature, there's going to be an increase in the sales of ice cream. So which means B cause A. Okay. So if you want to match, you're going to match that number one to the one that said B cause A. Then when you take a look at number two, ice cream sales and crime rate. Okay. Even though there could be an association between them, but we can never conclude causation. There could be some potential confounding variables that we don't observe that may be impacting the relationship between ice cream sales and crime rate. And that is why, if you take a look at this guy where I said C causing both A and B to change, there could be a particular variable C that is not observed, that is actually, influencing the relationship between ice cream sales and crime rate. If you take a look at number three, A temperature, B ice cream sales, of course, you're actually going to see a temperature is going to be causing ice cream sale, which is A causing B. Okay, and why is it difficult for us to conclude a causality? Okay, why is it difficult for us to actually conclude causation with observational study? Of course, why, and if that, of course, the reason why we are not able to establish a causation, from observational study is because of the fact that there could be some other potential variable that we don't observe, or that may not even be the primary of interest, that may be influencing the relationship. And that is the reason why, okay, if that happens, then we all know that the more appropriate research design should be experimental study. Okay, so why not experimental study? Because even experimental study in some situation is not visible. And these are the kind of situation that I want to highlight here. Number one, investigating whether, addedness affect mortality. Okay, and of course, we all know addedness cannot be assigned. Okay, and another one, investigating the effect of smoking during pregnancy on the child IQ. If I want to conduct an experiment in this situation, I have to assign, mothers, pregnant mothers, so to smoking, to experimental unit, to the experimental group, which is going to be, oh, I need you to be smoking, okay? And of course, I want to believe that is unethical. So even though that will give us, the best result, but it's not feasible. Then number three is investigating whether taking aspirin reduces the risk of heart attack. When you take a look at heart attack is a rare disease. Okay, it's occur in a blue moon, very, very rare. Okay, so the potential effect of heart attack may take years. Am I ready to be, to monitor this for years? Okay, so it could take years, and it's also costly, okay, in time and resources. Okay, and that is the reason why the only option that we have, okay, is to go for the observational study. But you and I know observational study cannot be used to make to conclude a concession. Then what can we do? Something needs to be done, okay, if we want to embark on all this. Any question before moving forward? Any question? Is there anyone want to ask question? Like I said in my class, I normally want a situation when student gets stuck, or maybe the way I talk, or maybe you don't get what I'm saying, please make sure you ask question. I'm actually here for you. Okay, you pay for the service. Okay, if I'm talking too much, or if I'm talking so fast or so slow, please let me know. Now, It is difficult to establish causal relationship from observational studies, but what are the things we can do? When we have a good design and some other reasons, and that very reasons, you know, what I'm going to explain, okay? If I want to conclude on causation with observational study, okay, I need to all of us have good design. So, how do we, put forward a good design? I'm going to walk you through that. Then what are the other reasons? Okay, then I'm also going to let you know. So which means if we really want to use observational study to conclude our conversation, then we should be ready to address the problem, the problem with observational study. And what is the problem with observational study? Why we cannot conclude on causation is because of the presence of either a locking variable or a confounding variable. Now we needed to introduce a synergy or a strategy that we potentially eliminate or make the effect of that to be evenly distributed across groups. Now, that was why you see the good study design is looking for a way to eliminate or control for confounding factors. And let me tell you this. If you want to control for confounding factors, where I'm actually want a situation where the confounding factor will be evenly distributed, okay, among the groups, then the idea that can be used is what we call matching. I'm going to give you an example of matching right now, okay? Now, let's say, for instance, you actually, what we want to study, we take a random sample of high school students, okay? And we actually want to compare our teaching method, okay? We want to compare teaching, so teaching methods, okay? We want to compare teaching methods, okay? Of course, if we want to compare our teaching method, what we're actually going to do, we're going to have, let's say, teaching method A here and teaching method B here, right? Okay, now, what we mean by, let's say, you are comparing a new teaching. Let's say this guy is new method, and this is the traditional, okay, that I actually call the conventional method. Now, if we want to do this, what we're actually going to do is we're going to use the idea of matching, okay? We're going to match subjects, students here to student here that have similar characteristics, and that very characteristic will be confounding variables. For instance, I want to look at the effect of teaching method now on exam and exam performance. Okay, exam performance is outcome. Exam performance is outcome variable. So this outcome variable, why teaching method is actually explanatory. The other time I told you you're going to have explanatory variable, you're going to have outcome variable, right? Okay, now, which means you want to investigate relationship between teaching method and the exam performance, and you want to do it in a way, even though we want to conduct observational study where the researcher is not going to have any interference, where the researcher is not going to conduct experiment, but what can we do, in order for us to use to conclude causation with observational study? Then we now need to match using the potential confounding variables. Now, what do you think could be some confounding variables that may be impacting analyzing the relationship between teaching method and the exam performance, the number one is going to be prior knowledge of the students. Okay, which I'm actually the prior knowledge of the students. So how can I measure the prior knowledge? The GPA of the students is one of the confounding variable. What about the other one? I can talk about like learning style, learning style, learning style of the student. I can also talk about socio-economic class of the students. Okay, socio-economic, okay, class. Okay, now I just identify 3 matching variable. You know what I'm going to do? I'm going to get student here. Let's say if I'm considering a GPA 3.5, I'm going to match student with GPA 3.5 with another student with the same GPA and with the same learning style, and they have to belong to the same socioeconomic class. Then I'm now going to conduct statistical analysis on the peers. Does that make sense? With that, you've already taken care of confounding variable. Does that make sense with how matching work right now? Okay. Now, another example. Is there anyone who need a clarification on this explanation on how matching work? Is there anyone? Okay, you understand that? Another example is I'm going to give you an example in when you're looking at the effect of exercise. You're looking at the effect of exercise on maybe cardiovascular health. When I talk about cardiovascular health, maybe I'm talking about blood pressure level, or I'm talking about cholesterol level. If I want to look at the effect of exercise on cardiovascular health, and I want to conclude on causation, then I need some confounding variables like 1, age. Okay. 2, gender. Okay. 3, physical, and so on. There could be a lot of potential, confounding variable. So if I want to do the matching, okay, in the exercise, you're going to have 2 groups. Okay. In the exercise, don't forget, you are looking at the effect. Okay. You are looking at the effect of the exercise. So in this group, those who do exercise and those, I'm going to say no exercise. Okay. Exercise, no exercise. You partition the set of individuals into 2. Now, if you want to do matching, okay, I'm going to take a female that is age maybe 40, female, age 40, and with the same similar characteristics with another female here, age 40, so they must have similar characteristics. Does that make sense? So with that, then you've been able to address the problem of confounding. Now, there's another example, the smoking versus lung cancer. What characteristics need to be matched up? The characteristics that need to be matched up are the confounding variables. So which means you need to review literature to be able to know what are the potential confounding variables if I'm looking at the relationship between 2 sets of variables. Does that make sense? That's what I mean. Now, but let me tell you this. In 1965, Sir Otto, there's somebody called Sir Otto Hill in 1965. In his article, he published, there was an article published in 1965 that he called environment. He called that environment environment, and disease. Okay, and it said association or causation. This is a player, an article, published in 1965 in the field of epidemiology. Okay, and of course, he provided some guidelines. Okay, some guidelines on how we can conclude causation, even with association. Okay, well, we conclude causation when association is involved, when you conduct a observational study. Okay, the full name is Sir Austin Bradford. Okay, Sir Austin Bradford E. Okay, so he actually called that the environment and disease. D, in case you want to read the article, the environment and disease, and it said association or causation. Okay, association or causation. Okay, now he identify this criteria. If you actually want to conclude, uh, before association can imply causations, what are the guidelines? Okay, the guidelines number one is temporality. Okay, it's temporality. The temporality is trying to say, okay, before effect, there must be a cause. That is the meaning. Before effect. The other time I gave you an example where I'm looking at effect of teaching method on exam performance. So which means teaching method precede the exam performance. Does that make sense? We also call that exposure. Okay, we call that exposure. Okay, then we call the response. So this is response. This is explanatory. So what we're trying to say, exposure must precede outcome. Before outcome, then we actually have something responsible for the outcome. That is what we call temporality, according to Sir Austin Bradford, 1965. Okay, then another criteria used by this person is the strength of association. Don't forget, when I look at the association between variables, okay, I can also determine what is the strength of the association. Like if you are working with continuous random variable, I know you use correlation, right? If you are working with, maybe a situation where you are looking at, the connection between exposure and outcome, we make use of odd ratio. Of course, we're going to look at the magnitude of odd ratio. It's going to tell us how strong is the association. So according to Sir Austin Bradford, 1965, he said, if the association between variable is strong, then that's actually it's one of the signs that we can conclude causation. Does that make sense? So which means he actually prefers stronger association to weaker association. Then number three is biological plausibility. And that was why I said must be able to make an argument that exposure could be biologically cause the outcome. Let me tell you this. There's a difference between statistical connection and biological connection. We want a situation where the two, they will go together. Because you can establish an association statistically. Is that the way it is biologically? And that's why at times, if we are working with this area, we need to work with biologists. If you are working with biology, as statisticians, analyzing biological variables, of course, you need to be able to liaise or collaborate with those who are in the field to be able to see what you have been relationship that you have been able to establish statistically, is it also established biologically? And this is one of the criteria. Another criteria is consistency. What do we mean by consistency? If I said, okay, the relationship between this variable and this variable in this study is actually this. In another study, if I'm considering these two variable, it should be the same relationship. That's what we mean by consistency. It shouldn't be the one that I conducted in state of Minnesota, and between maybe in the state of Minnesota, I actually conducted, maybe I look at the relationship between what is it called? The method of teaching and exam performance in Minnesota. And by the time I go to Pennsylvania and I do the same with the two variables, it should be the same decision. Otherwise, if the decision, if the observation is different at different circumstances or in different settings, then that does not qualify, for a situation where we're going to conclude on causation. Okay, I think I'm going to give, in addition to this, um, we also have more that I'm going to call coherence. Okay, because there are more, if you read that article, you're actually going to see, more. Okay, there's something that we call coherence. Okay, so the coherent is just, the interpretation we're going to give has to be the same. Okay, so the cause and effect interpretation should be coherent with the existing knowledge. Okay, and must not contradict. This is what happened. I'm not going to say existing knowledge cannot change. Existing knowledge can still change because, day by day, we can discover new things, okay, that go against the norm. But, um, if the existing knowledge is strong, like the reason that back and existing knowledge is very, very strong, then whatever we establish has to coherent, with that. That's what we call the coherence. Okay, but let me tell you this. If only one of these guidelines given by EU is met, it's just only one, then we cannot conclude on causation. So and that was why I said the more criteria you satisfy, the better. In fact, if you're able to satisfy most of these criteria, that is a strong evidence for causation. And I give an example. Situation where there's a strong, if you want to base it on only one, if a strong association exists between the ice cream sales and a crime rate, does that mean we should conclude causation? No, because that is just on the strength of association, based on the strength of association alone, or based on the if one of the criteria is met, just only one is met, it is not enough evidence to conclude causation when you conduct observational study. So what we want to encourage is when a good number of this criteria is met. Is there any question before I move on? If I were you, make sure you cite your example. I remember when I was in college, what I normally do is I normally start my own example. It's only when you cite an example that you really understand the information. Now, at this point, I want to go to type of observational studies. Excuse me. What I walk you through now is for you to be able to see, what we need to do before we can actually conclude causation with observational study. But what we want to do now is, can we also exploit the types of observational studies we got around? Now, let me tell you this. We can categorize that into two. If I want to talk about observational study that is based on outcome, when outcome happen, outcome is the same thing as response, which is effect. If I want to base it on that, then I'm actually going to talk about retrospective study and prospective study. Now, I need you to look at the word retrospective. The word retrospective is you are actually going back, like going backward. We observe the outcome using past record. Okay. Now, I'm going to explain that retrospective to you and the perspective when we get to cohorts and the case control. Okay. But what I just want you to uh, know about the retrospective and prospective is that an event the event of interest, the outcome of interest has already occurred. Okay. And data is available for that. So that is the retrospective, even though it has an issue of recall bias. But prospective means that right now, this particular guy, maybe I want to look at the effect of smoking on the risk of getting lung cancer. So, for prospective, this guy is already smoking, and I'm observing this guy. Okay, some not is smoking. Some are smoking, some are not, and I'm observing them simultaneously. And what am I waiting for? I'm actually waiting to see whether they're going to develop certain health condition like a lung cancer. That is what we call prospective, waiting for outcome to happen, which means they are currently exposed. Does that make sense? They are currently exposed. Right now, some of them are smoking, some of them are not smoking, and we're waiting to see whether outcome is going to, a particular event is going to happen following that. And when that happens, then we can now draw a kind of connection. Does that make sense between the variables? Now, another category is when observation is based on, how sample was taken. Let me tell you this. When you are actually using observational study design, okay, the way we take our sample, we may take our sample based on outcome. It means outcome has already occurred. What is the outcome? Maybe somebody already have a lung cancer. Some have lung cancer. Some do not have. When I say outcome may be they have or they do not have. Does that make sense? If they have a certain condition, certain outcome of interest, or they do not have certain outcome of interest, can we trace back to their exposure? You understand now? So that is what I mean by, so based on how it was taken, when you take a look at cohort now, okay, the cohort is actually, it means presently, okay. In fact, there are two types of cohorts. Let me start with the cohort, okay. Let me start with the cohort. Now, cohort can be prospective, cohort can be retrospective. I'm talking about cohort right now. Cohort can be prospective and can also be retrospective. Now, even though here I mentioned exposure, but let me explain this to you. By cohort means I'm following some individuals. With the fact that I'm following them, I'm monitoring them, okay, means that they are in my cohort. Okay. Now I follow them over a period of time. And when I follow them over a period of time, okay, let's say for perspective, those people that I'm following, they have already exposed. They've been exposed. And why am I following them? I'm waiting for an outcome of interest to happen so that I'll be able to draw a connection. But for retrospective in the cohort, okay, outcome of interest, outcome already happened, but I want to look back to their exposure. Does that make sense? That is a cohort. So what I'm trying to say in a sense, cohort can be prospective, can also be retrospective. Okay, for prospective is looking forward, which means they already exposed. I just talked about looking at the effects of smoking. So maybe they're already smoking, okay? And I want to see the outcome is lung cancer. So here, they're already smoking, and I'm monitoring them to wait for the occurrence of event of lung cancer or not. Then here, for the retrospective, this individual that we selected here, the outcome of interest has already occurred. And what we want to do is to look back. When this occur, we want to look back and see maybe the reason why this occur is because they've been exposed. Maybe they were smoking or something. Does that make sense? So that is what we mean by cohort study. But when we talk about case control study, for the case control study, I'm actually going to take, I'm going to identify those who have the disease. Okay, let me use this. Those who have lung cancer and those who do not have. In the case of cohort, I did not look for those who do not have. In the case of this one, in the case of cohort, I actually identify individuals who are already exposed for prospective, and individuals whose outcome of interest have already occurred, and I want to look back. There's nothing like control here, but in the case of case control study, that's why it's called case control. Okay, I will identify individuals with the outcome of interest, and I will also identify individual without the outcome of interest. So the individual, why am I getting to is for comparison. There's going to be a control. Okay, now, so that is what we mean by the case control study. And when I identify them, don't forget case control. When I identify individual, okay, with outcome of interest, and individual without outcome of interest, of course, don't forget that is where matching is going to take place, where I'm actually going to match subject in two different groups using confounding variable. Now, the last one is what we call cross-sectional. The cross-sectional is we don't put into consideration income, outcome or exposure. For cross-sectional, we only collect data across individuals at a particular point in time. Okay, now at a particular point in time, we can only talk about what happened at that time with the cross-sectional. Okay, it's only going to be what happened at that point. For anything beyond that time period, then the case control, the cross-sectional is not the result of cross-sectional is no longer binding. Okay, and now I'm going to give you an example now. Take a look at this. This is an example of case control. Why do I say case control? Okay, take a look at this. I underline, take a look at this. Give me 1 second. I'm gonna now take a look at this guy. What do you see? You can see 25, 25. It means I identify individuals with outcome of interest and individual without the outcome of interest. It means some 25 has lung cancer and 25 have no lung cancer. Then we're going to ask them question looking back whether they have smoking history or not. This is what we mean. This is the case control study. So with the case control study, we are sampling with respect to the outcome. Okay? Respect to the outcome. Now, in the cohort study, please take a look at this. We're focusing on the exposure. In the cohort study, focusing on the exposure. Right now, 25 people are already smoking and 25 are not. Okay? And what are we waiting for? We are actually waiting to see whether event of outcome of interest is going to happen. So take a look at that. But for cross-sectional study, okay, like I said, we normally, the way we sample people, we don't put into consideration the outcome and the exposure. Okay, So take a look at that. Okay, I think I put some pictures here that may be helpful. If you take a look at the first one, okay, if you take a look at this guy, okay, if you take a look at what you are saying right now, okay, somebody already have a disease. Then what are we trying to do? Oh, we want to look back, okay? What was do they have exposure or not? That was why I put a question mark on the exposure. They already have the disease, okay? So take a look at that. Now, let's take a look at the second one, okay? In the second one, what happened? They are already exposed. What are we waiting for? They are exposed, okay? Whether they are drinking, some are drinking right now, some are not drinking right now. And what are we waiting for? We're waiting to see whether there's going to be occurrence of disease, whether they have it or not. And that's why you see prospective, right? Then if you take a look at the third one, okay? If you take a look at the third one, don't forget, I told you, cohort can be divided into prospective and retrospective. The third one is talking about retrospective cohort. Okay, you can see retrospective cohort, you can see, and the other one I talk about is the prospective one. Oh, go ahead. Oh, odd ratio. RR is relative risk. Oh, let me write it. That's a good question. RR relative risk, and OR odd ratio. We're still going to talk about all of that. That's a good question. Thank you for asking that question. Okay, now this is just to tell you advantages and disadvantages, with cross-sectional study. Cross-sectional study is not useful for cause and effect. Don't forget, for cross-sectional study, you collect data across individual at a particular time period. Okay, whatever decision you're going to make is just based on that time period. Okay, then for the case control study, take a look at that. And let me tell you this. In the case control study, do you know what we normally investigate? We normally conduct statistical analysis on exposure, comparing exposures in case and control. And that is why we normally make use of odd ratio in that regard. Okay? Because don't forget, some people have disease, some do not have disease. And what the analysis is going to base on whether they are exposed or not. And that is why they have the disease or not. Okay? And the strength of the odd ratio will determine the cause and effect. So may provide evidence for possible cause and effect relationship between exposures and outcome. Okay? So cannot be used to estimate prevalence, what proportion of the population have the disease. So I'm just trying to let you know about what is advantages and disadvantages of all of that. Then selection of appropriate controls can be difficult. Because with the case control study, I need to select individuals who are actually, who have the disease, individual who do not have the disease. And let me tell you, how am I going to, what criteria, selecting those who do not have the outcome of interest may be difficult. Because how do I know they don't have? Like, you understand what I mean? Some, maybe they have the disease before, and it has been cured, and there's possibility that disease can also come back, can reoccur. So that may be difficult. For example, in a study about association between cell phone use and brain tumor, so what are we going to use as control? That may be difficult. Now, for cohort study, actually provide evidence for possible cause and effect relationship between exposures and outcome, but may be time consuming. Don't forget in research, there's some research that we need to get result on time. Okay, that we can't wait. If we wait, something is going to happen. Okay, and potential for high dropout or loss to follow-up rate. You know, those in our cohort, we may lose some of them. In fact, some of them could relocate. They could relocate. Maybe we're monitoring them in Minnesota, right? They can decide to go to another state or even go to another country. Okay, they're not suitable for very rare outcomes. You remember the other time when we talked about looking at the effect of aspirin on preventing heart attack. So if you want to work on a rare event like heart attack, then the cohort study may not be a very good observational study for that. I think I put a guess here. Take a guess. What type of study finally provided conclusive evidence that smoking is a risk factor for lung cancer? So you can try to study that and see which one is it? Is it going to be cohort? Is it going to be case control? Is it going to be cross-sectional? Okay, and so on. We know the best one is experimental study, but experimental study may not be this. So if you want to learn more about that, you can click on that very link. I think I got some references here that's going to help you out. Okay. I will advise that you say that 2015, even though that 2020 is a note, but I will advise, yeah, that was part of the note that I used. But look at that 2015, seeing through statistics. You know, statistics provide us an opportunity to be able to see the world more clearly. A lot of things are hidden in, you know, that we may not be able to see. Even when you have your data set, the data set have information that are hidden, and you need to have the knowledge of statistics to be able to know which are appropriate model to be used to get information that are hidden in the data. And that is the reason why statistics provide us opportunity to see the world clearly through statistics. And that's why we're encouraging people outside there to have statistical knowledge. Is there any question before I go? Okay, this is what I want to do. This is what I normally do. I need you to send me a message. And that very message is, this is going to be like maybe that fourth class or third class in the semester. I need you to rate your understanding, like rate your understanding, rate your understanding of what you've been learning. Here, and I need you to, like when I say rate, if you understand 100%, please let me know. Right, 100%. If you understand 0%, let me know. If you understand less than 100%, give reason or reason why you believe that you may think that may be attributed to me, because one of the things that make me going in teaching, like doing great in teaching, is when I hear feedback from students. Okay, do not hide your feelings. I want to hear from you. That will help us together, and that will help the university, and that will help the system, and that will help the world in general. Make sure you all stay safe and have a lovely day. Bye for now, everyone.